partitioning shapes into equal areas, we're going to look at thirds and sixths. Third can be called, it can be 1/3, or you can call it thirds, sixths, or sixths. Notice the key thing here is you want equal areas. So we're pretending that this circle is 1, 2, 3 equal areas, or thirds. And this one would be 6. 1, 2, 3, 4, 5, 6. One interesting thing I want you to look at throughout the video is that ultimately the sixths can look a lot like the thirds, just kind of cut in half. So let's take a look at 1/3 here. We have a rectangle cut into 3 equal parts. Nice. And then we just have that flipped on its side, cut into 3 equal parts like that. And then down here we have 3 parts, but they're not equal. So, nope, this one's not thirds. Sixths. We have a rectangle here, we cut it into 1, 2, 3, 4, 5, 6 equal parts. And if you notice, if you just look at your every other sixth, right there you have thirds. Or if I come back to the thirds and I split each one into half, I have 1, 2, 3, 4, 5, 6. So thirds and sixths are very closely related. Pretty much if you can split it into thirds, you can split it into sixths. 1, 2, 3, 4, 5, 6 this way. Down here, I have a rectangle. I drew a line across, made an X, and then I have 1, 2, 3, 4, 5, 6, but they're not equal, so it's not sixths because they're not equal. More thirds and sixths. The rule of thumb is whatever your denominator is, thirds. If I draw a polygon with that many sides and all the sides are equal, connect them at the center. 3 sides is a triangle. 1, 2, 3. Now connect them in the middle. 1, 2, 3. If all these sides are equal and I bring them from each corner to the middle, I'll have 3 equal triangles or thirds. You can also just cut those into halves now, and each one of them would be an equal sixth. Again, starting with a triangle where all the sides are equal, connect at the center, and then split those in half, you'll end up with sixths. This, however, would not work. Drawing lines straight down, you don't have equal triangles. Then we take this shape here. What it is, it's a hexagon. 1, 2, 3, 4, 5, 6. A 6-sided shape. All the sides are equal. Well, I can do that in a sixth easily, but you can also do it into thirds. Take every other corner, corner to the center, skip, corner to the center, skip, corner to the center, and now I have 3, well, they're called rhombuses, that are each equal and they're thirds. This is a hexagon split into 6. Basically the same shape, but I just did it with every corner to the middle, and now I have sixths instead of thirds. This is a trapezoid split into thirds and sixths. Here's what it is. You take it, you kind of draw a little V in the middle, and that's basically 3 triangles coming together to make a trapezoid, and they're all equal, so I have thirds. With 6, it's the same thing. You just split each triangle in half, and they face back to back, so it looks a little bit different down here. You can see this is 1/3, this would be 2/3, 3/3, or 1, 2, 3, 4, 5, 6, and this is what it would look like all put together. Another way is just kind of build. I took some blocks and I made a little shape here. This is 1/3, 2/3, 3/3. So I put each shape itself, connected them all together, and made a weird looking polygon, but it's thirds because they're all equal. Each one is 3 unit squares in area. Now I still have that 3 unit square area here, but this time I'm looking at sixths. So instead of just drawing 3 of them, I drew 6. 1, 2, 3, 4, 5, 6. So now I have sixths and thirds. I can partition shapes into, should be not halves, sixths and thirds with equal areas. So here's a trapezoid. Partition this into thirds. Then get a piece of paper, fold the paper into 6. This would be a great way to actually partition a paper into 6 equal boxes for the 6 slides that you could take notes on.